Okay, in this lesson we're going to be looking at applications of trigonometric ratios. So we're going to be looking at word problems where we have to use one of the three ratios, sine, cosine, or tangent, to determine some measurement in this sort of real life scenario. So there's two terms we need to know before we can move forward with these word problems. They refer to different angles. So the angle of elevation, also known as the angle of inclination, would be the angle that you, like between the horizontal, so a horizontal line is like a flat line going that way, and the line of sight. So it's essentially the angle your head would have to move to look at a certain object. So it's referring to this angle here. So that's the angle of inclination or elevation. Now the angle of depression is if you were looking like downwards to something. So depression, think downwards, starts with a D. So the angle of depression would be, but still between the horizontal, but it's the angle your head would have to move down to look at something. So imagine you were standing on a cliff or something and you would have to look down towards a boat in the water. That's the angle of depression, also known as the angle of descent. Okay, so in all three of these scenarios, we're going to have to draw a picture and we'll have to label either the angle of depression or the angle of elevation. Okay, example 1. An airplane at an altitude of 850 meters is observed by an air traffic controller at an angle of elevation of 52 degrees. What is the distance from the airplane to the tower? Express your answer to the nearest meter. Okay, so we have our air traffic controller and we have our airplane in the sky. Now you don't even have to draw a plane. It's a terrible drawing of a plane, but I'll just label it plane here and I'll call it air traffic controller is standing down here. Okay, and let's draw a dotted line from the air traffic controller to the plane. That is the distance we want to find, x. Okay, we also know that the altitude of the plane itself, so altitude means distance above the ground, is given to us. So that would be 850 meters. I'm going to draw another dotted line here. So you see the right triangle forming. So your diagrams should have a right triangle in them. And it says the air traffic controller has an angle of elevation to the plane of 52 degrees. So it's always the angle with the horizontal line. So it's like this angle, this air traffic controller would have to move their head upwards to look at that plane. So that is 52 degrees. Now step 1 is always label your sides. So the side opposite to the 52 degrees, so we're concerned with this angle here, so we're labeling everything based on that. This is the opposite side. And then this is the hypotenuse, it's the longest side. And then this side here is the adjacent. Okay, and let's write out SOHCAHTOA so we can determine which ratio to use. Now I want to avoid one with the adjacent because I'm not trying to find the adjacent and I don't have the adjacent length. So I'm looking for a ratio that has the opposite and the hypotenuse, which is sine. Now I don't want to use cosine or tangent because they both have adjacent in them. So I'm going to write out my ratio here. Sine of angle 52 degrees is opposite, so 850 meters, divided by hypotenuse, which is what I'm trying to find. Label it x. And for this one, we're solving for x using algebra. We can essentially switch the places of x and sine of 52. So multiply both sides by x, divide by sine 52. And we get x is 850 divided by sine of 52 degrees. And that's what I'm going to punch into my calculator. Let's clear everything here. So 850 divided by, and I type 52 and then I press sine. Close my bracket. Okay, equals 1078. And it says express your answer to the nearest meter. So 1079. So x is about 1079 meters. We want to make sure to use the correct units. So everything's measured in meters here. So I'm going to use meters and I've rounded it to the correct place, to the nearest meter. Okay, there we go. So that was an example where we used the angle of elevation. So somebody was looking upwards at something. So I'm just going to label that here. Next one we're going to be looking downwards, so we'll see an angle of depression. It says Cape Beale Lighthouse in BC is on a cliff that is 51 meters above sea level. A lighthouse keeper who is 10 meters above the ground in the lighthouse observes the boat at an angle of depression of 50 degrees. So here we're doing an angle of depression. How far is the boat from the base of the cliff to the nearest meter? Okay, so let's draw this scenario. So we have this cliff, and then we have a lighthouse on top of the cliff. So the lighthouse person is standing up here. Okay, so this distance here is 51 plus another 10, so 61 meters from the base of the cliff. Then we have some water, and we have a boat. Actually, I'll do that as a dotted line. We have a boat sitting down here. Let's do a really simple looking boat. And the lighthouse keeper has an angle of depression, so when he moves his head down, oh, actually, I've labeled that wrong. Okay, so here's where it's a little bit tricky. The horizontal is here. So when the lighthouse keeper moves his head downwards, this is the angle of depression. So the angle of depression is always, I'm going to use my blue highlighter here, with the horizontal. So that's 50 degrees. So if I want to use the angle that's in the triangle there, I'm going to have to subtract from 90. So I'm going to use my pink pen here instead. So this angle here would be 90 minus 50 degrees. So it would be 40 degrees. Okay, so we have to be careful when we're labeling our angle of depression. It's always with the horizontal line. So it's like as if your head was looking straight and then what angle you would move down to see the object. We also know that this is 61. Okay, so let's label everything. So this would be the opposite side. This would be the adjacent. And this would be the hypotenuse. So in this case, we want to find the opposite side. I'm going to label that with X, because it says find the distance the boat is to the base of the cliff. So that would be the X there that I'm trying to find. So I'm concerned with the opposite side here and the adjacent side. I don't so much care about the hypotenuse in this scenario. So when I write out SOHCAHTOA, I'm looking for the ratio that does not involve hypotenuse. So I'm going to use the tangent ratio, which involves the opposite and the adjacent. So let's write out our tangent ratio. So tan of 40 degrees is the opposite side, so X, over the adjacent side, 61. And in this case, I'm going to solve for X by multiplying both sides by 61. That cancels out the division by 61 on the right-hand side. So I get X is equal to, and this is what I'll type into my calculator, 61 times tan, tangent of 40 degrees. So let's see what I get. So for me, I'm going to type 40 degrees, and then I press tangent, and then I'm going to multiply this answer by 61. So I get about 51.2. Now it says nearest meters, so about 51 meters. So X is about 51 meters. Okay. Actually, I'll use a little squiggly there. Okay. There we go. Okay. Next example, we're not going to use an angle of depression or elevation. It's going to be sort of a direction-based question based on north, south, east, west. Okay. So this one, the diagram is really important. So it says the ship is sailing from an island due north. So that means it's traveling straight north. And when the ship is 15 kilometers offshore, it turns and travels east for 10 kilometers. What's the angle between the ship's path eastward and the line of sight back towards the island now? So first we're just going to go over like how we would draw directions on a flat piece of paper. So north is always straight up towards the top of the paper just by convention, and south is opposite of that, and then west is this way and east is this way. Sometimes people think of it as like if you go clockwise around, it's never eat soggy wieners. That's how I always remember it. Okay, so it says our ship is starting from an island. and it travels straight north. It says for 15 kilometers. And then it turns and travels east. So east in the right, going to the right side of the page to some point. We don't really know. Oh, it travels east for 10 kilometers. Okay. And then here's our right triangle. So we are trying to find the angle between the ship's path eastward. So I'm going to highlight that. And the line of sight back to the island now. So here's the ship. The line of sight back to the island would be the line that you would look back towards the island along. So the angle between the blue and the yellow lines there. So of course we are looking for this angle. Sometimes students struggle finding like which angle to actually solve for. So we are finding this. I'm going to call it angle A, just so we have something to call it. Okay, so if that's the angle we want, then this one would be the opposite side. And this would be the adjacent side right next to the angle. Wow, I didn't spell that right. Let's fix that. Okay, so if I write out SOHCAHTOA, I don't want any with the hypotenuse because I only have the opposite and the adjacent, so I'm going to use the tangent ratio again. So tan of my angle A, which I don't know, is the opposite, so 15 over 10. Now this one I'm finding the angle, so I'm going to use the inverse tan button. So angle A is going to be the inverse tangent of 15 divided by 10. So let's type that into my calculator and see what I get. So 15 divided by 10, and then I'm going to do the inverse tangent of that. About 56 degrees. The question doesn't tell me what to round to, so I'm just going to assume it's to the nearest degree. So this in my diagram there, that angle would be 56 degrees, approximately. Okay, and that's the end of that lesson.